Welcome. So today we'll be covering Modbus with the CIMON PLC, specifically, just how to use the server or the master feature with the the CIMON PLC, and then maybe I'll touch base on HMI and some other protocols later after we go through Modbus. But yes, with further ado, let's begin. Without further ado, let's begin. Okay, so today we're going to be covering CIMON PLC with Modbus. Okay, so what is Modbus? It's here's your formal definition. It was invented by Modicon a long time ago. It's an open source protocol, and also it could be classified as a universal translator. So I'm not going to read everything on this slide for you. There are underlined words for you, so you can just like latch onto those words. Common use cases is when we want to have like an HMI or a SCADA collecting data from multiple brands. So if you have like an Allen Bradley PLC, a Siemens PLC, Mitsubishi, like you have all these different devices that you never programmed, but you're being contracted to have them communicate with one another, and you're not able to like fit them with different PLCs, you could take an HMI and just use Modbus. Most devices, and I'm saying like, this very loosely, about 95% of devices in this field will support Modbus. So if you're being dealt like a random hand, you can definitely talk to all these devices with Modbus. I almost guarantee each device will communicate with Modbus. And then when you want to talk to maybe servo drives, a PLC could communicate over an Ethernet protocol such as Modbus when you're trying to control a servo. Alternate ways of controlling a servo might be like EtherCAT, Profinet, standard digital outputs, like controlling the number of pulses that you send towards a stepper motor, something of that nature. And then when you have different brand PLCs communicating, I just mentioned this, but like you want to send all that data to like a SCADA to an HMI, you would use the Modbus protocol. Or you could use something similar, OPCUA, that might be a new term for some of you, or might not be for some. OPCUA stands for Open Protocol Communication. It's another company. It's not really open source, but it's typically free to use, as from my experience. And at least with the CIMON software and hardware, it's free to use. So if you were to use our SCADA software or our HMI software, it would be free to use. You wouldn't have to purchase it additionally. And so the reason I make that point is OPCUA could be considered a universal translator as well, because that's the growing in popularity in terms of universal protocols. So if we look at Modbus, slides are just messing with me. Okay, so if we look at Modbus, we have read registers and we have read-write registers. It's a little archaic, right? So it's old, but like it's still set in this field, and it's good to know because you're going to come across Modbus at some point in your industrial automation career. So on the left-hand side, we have the read registers, we have discrete inputs and input registers, and then on the right side, we have coils and holding registers. So what I like to point out is that our read-only registers, they start with an odd number, so 1 or 3. And then on the right side, our read-write registers start with a 0 or a 4, which is an even number. That's just one way I memorize it. I mean, if you have a different way of memorizing, I would latch onto that type of methodology. But I just, read write, I do even numbers, and then read, I do odd numbers in my head. And then we have the zeros and ones for our digital inputs and digital outputs. So if you look at zeros and one, that is a Boolean value, 0 and 1. So that's how I remember that the zeros and the ones are for your digitals, your discrete values. Zeros being your read-write Booleans, and then ones being your read-only Booleans. So when we talk about this architecture, we have like a Modbus master and a Modbus slave. So you have the client, and then you have the server. The server is hosting all of these registers, and the client is either reading or read-writing from those registers. And then we have holding registers and input registers as well. So 4s and 3s, those numbers are larger than a 0 and 1. So I usually remember that as being our analog registers. So that means like integer, double integer, or float. And from these registers right here, you cannot transmit string data. There is Modbus ASCII out there, but we will not be covering that today. We're just going to be covering Boolean and analog registers. So once again, 0s and 4, those are even numbers. That's read-write. Ones and threes, those are odd numbers. Those are read-only. 0 and 1 are going to be your Boolean registers, 0 and 1, like a Boolean value. Fours and threes are going to be your analog registers. So here's a more formal table for these. There's function codes in the middle. I would not get too hung up on the function codes. They're technically, you don't really need to memorize them. It's more just for completeness sake on this presentation. But I will tell you that it is not available to write onto multiple coils from the CIMON PLC. So you'll have to create individual frames that write single coils. It's not a huge deal. It's just something that we don't support currently. So that is not available. You'd have to create multiple write single coil frames. So let's talk about a Modbus example. So for a Modbus example, we have a CIMON PLC or a CIMON HMI, doesn't matter, or a CIMON PLC. It doesn't, it doesn't matter how you set up this communication. You will have to use Modbus, or I want us to use Modbus in this example. So it doesn't matter what device you're using from CIMON, we will support Modbus protocol. And then we're going to be talking to an Allen Bradley Micrologics SLC 5 or a SLC 5. And we're going to be talking to these registers. So like maybe a B314/2 or maybe an O12/14/2, something of that nature. Inherently, these registers can't talk to each other. So we need some type of bridge that, takes that into account. So then we can have registers like these Modbus addresses. So if we look at the Allen Bradley device, B3:14/2, we can host that register on the address 00006. And then with the CIMON device, we will target that Modbus address and be able to collect the data from this register. So we're just dealing with the middleman, a common phrase, So we're going to use the CIMON device. We're going to allocate M100 target, and that will target 0006, that Modbus register. And then we'll grab the data from the Allen Bradley device and we can store it in our device on M100. Same thing can be said for N7. We'll store that onto the register 40,002. And if you're wondering, how do you set up this type of configuration? Both configurations need to be set up in the separate devices. So inside the Allen Bradley Micrologic software, you're going to allocate these registers to these Modbus registers. Like you literally do that within the Allen Bradley software. There will be a configuration screen. It'll ask you, where are you wanting to allocate these registers to? And then you declare which Modbus addresses you want to host those on. And then on the CIMON side, you declare, hey, I want M100 to target this address. So then you do some you have to do some configuration on the CIMON side, and you have to do some configuration on the Allen Bradley side. But that is a very common approach to any type of device. Sometimes Modbus is natively active, like on a CIMON device, and there's little to no configuration, but you will still have to identify which register is being allocated to which Modbus register. So Allen Bradley, you're gonna say, hey, I want B3:14/2 to be hosted on 0006 within their software. And then on the CIMON software, you're going to say, hey, I want M100 to point to 0006. And then you will grab the data from the Allen Bradley PLC and then host it onto your CIMON device. You'll be able to read it from it. Going down the list, I put an X over the X register right here. And then I replaced it with M101. So this is to paint a lesson that you cannot do this. And why can't you do this? Because we have a read-only register talking to a read-only register. That doesn't make sense. So 10003, if we recall, the one register is a read-only. So the 10003 register can actually host I2.2/3. This is a read-only register. This is a physical input on the Allen Bradley software. So that's why it's read-only, because you have to actually provide an external signal to turn this register on. So you're hosting a read-only register onto the 10003. But then you can't read that value onto an X register, because just like the I register is a physical input, the X register on a CIMON PLC is also a physical input. So you're going to have to use a register that can be written onto. So that would be like an M register or a Y register. That's why I'm replacing X with M right here. And vice versa, you would not be able to use an I to read from an X. It just doesn't work that way because they're physical inputs. Okay, so there are some considerations that we need to take into account when we look at Modbus. And some of those would be offset registers. So there is one based, and then there is a zero based, right? So sometimes this is a very common mistake or a common, consideration that's not taken into account when you're doing like a Modbus hosting. Like you'll be like if you look at the user manual, it'll tell you, oh, 40,501 is hosting this register, and then you target that register with your device, and for some reason it's not actually targeted, like you're not getting the correct value. And the thing is, if you target its neighbor, 40,502, you'll find out, hey, that's where the actual address is stored. And it can be the difference between a zero-based and a one-based starting register. So for example, 00000, this register right here is the same thing as 00001. It's the starting register. So you need to make sure you take into account of offset. So if you don't get the value that you're looking for, check the neighboring registers. That might solve your issue. Expanded Modbus range. So it used to be the case that it only went up to like a certain number, but now we support up to a word, so 65,536. We support that many registers, so it's 5-based versus 6-based. So we only used to go up to 9,999, and now we go up to like your six places. Now you get 65,536. And then always make sure that or you have to know if they're using hexadecimal on the target device. So if we look here below, the 064087, that doesn't look like a hexadecimal value, but that could be a hexadecimal value. You don't know. That could be a hexadecimal value, but you would only know when you look at the user manual. So making sure that could be a reason why you're not communicating correctly. So you would want to take that and then convert it to a decimal, and then you find the actual register. So for example, 0FA57, you just convert that to its decimal counterpoint or counterpart, and you would target that register, and then you would definitely be able to map onto that register with your device. Just make sure you take into account for hexadecimal and offset register. Check neighboring registers in case you didn't get the right value, and check for hexadecimal. Also, another consideration I didn't put on here is like little endian versus big endian. That's also, you're going to need to take that into account when you're doing you might need to do like a word swap or like a byte swap when you're talking to certain registers. All right, so what does the Modbus slave server look like on the CIMON PLC? First off, it's natively active. Second off, you're just going to match your communication parameters. So that means you need to match your slave ID, your server ID on the PLC to whatever you're targeting on the client. And then other than that, you just need to look at your Ethernet port and make sure the IP address is correct, or your serial communication channels, the baud rate is correct, and then the other parameters. The configuration tab is the same for RTU and TCP. You're using the same Modbus tab inherently. So the same registers are being hosted on the CPU. You just change the slave ID. And then careful for hexadecimal hops. So what I mean by that is that if we look at X00, we start at 10001, right? But if we look at Y10, you would think that that would be 00011 because it's one more, it's one greater than, right? Like here, X00, it was one greater than, and then Y10, you're going to be like, oh, that's Y11, right? No, that's incorrect, because in the CIMON PLC, we use hexadecimal addressing. So after 9 is actually A, and then you would use A as like, that would be your 11. That would be your 00011. So Y10 is actually the 16th register in that, or the 17th register within that file register, and that's why it's 00017. That's why we offer these tooltips, so you can easily identify what Modbus register is actually being used, so you don't even have to think about it, honestly. So whenever you use a register, just hover your mouse over the coil or the contact, and it will tell you the Modbus address for you. And that's pretty much it for Modbus slave on the CPU. So if you're going to use an HMI, right, like a CIMON HMI or someone else's HMI, you're going to have to create an I/O device. You're going to have to enable the Modbus master protocol at some point. So you're going to go to the I/O device, and in this example, I'm using xPanel Designer, which is a software that is created by CIMON. And then you're going to create a new device. You're going to select Modbus. You can choose serial or Ethernet. You're going to want to make sure that the COM parameters match correctly. So that means like the COM port is declared properly, the baud rate, the parity, all that fun stuff. And then you select the COM type to be correct. And then you're going to go over to station. And in the station, you're going to want to choose the correct station type, station number, and then whether you want like an error message to show up or not, and then if you're going to do a byte swap or a word swap. And then when you go into your database, you're going to use the correct addressing, which is the Modbus addressing as your IO address. So that's pretty much how you set up a Modbus register within, or a Modbus protocol within xPanel Designer. And it's similar for the Canvas software too. And the Canvas software is our newer, latest HMI software, by the way. So when you're creating a tag, you literally just name it real tag, or you declare it to be a real tag, select the protocol, and then the IO address as such. And then you can do the same thing for an analog register as well. When you're creating that dynamic tag, you'll select the tag that you made, and then make sure that the COM parameters within the PLC, they match, right? So you want to make sure the station number matches, and the baud rate, the parity, all of that fun stuff needs to match correctly. So if we go back here, these are the same COM parameters that we just saw in the PLC software. So 9600, none, 8, 1. And then we want to go to Modbus and make sure that slave ID is correct, that station number. And then the xPanel will communicate with the Modbus addresses 001, 40001 via Modbus RTU protocol, which in return reads writes the registers onto, or it read writes the registers from Y00 and D00. Why is it those registers? Because we declared in the CIMON PLC that Y00 is being mapped onto 001 and that D00 is being mapped onto 40001. Where did we do that? We did that right here. In the Modbus tab right here, Y00 is mapped onto 001. That's the starting address. And then D00 is being mapped onto 40001. So it is natively set up like that. You can always change it, but that's how we declared our allocations. They're already being done for you. The PLC logic will interact with it, and then you can manipulate those Modbus addresses as you see fit. So how would I use the PLC as a Modbus master? So to use the PLC as a Modbus master, not the HMI anymore, we're going to create a program, and there's a program called Modbus master. And then you're going to get a program like this to show up, and then you're going to create individual frames. So you're going to make sure you target the station number correctly, so the slave ID. So we are the server, we're the client now, right? So we're targeting the server, we're the master targeting the client, or the master targeting the slave or the server. So we want to make sure we enter in the correct station number, that's the slave ID. The correct function, you don't need to know the function. You can look over to the right-hand side. That's the register you're going to be talking to, the zeros, the ones, the fours, or the threes. And then whether you're going to be reading or writing from them. So it's a little bit more cumbersome in the PLC software. I really recommend using an HMI as your Modbus master, but if you're forced to use a PLC as a Modbus master, you will need to make sure you pay attention whether you're choosing read or write. So force and preset are going to be your writing, and then reading is going to be, of course, reading. And then you're going to choose your data size. So you can choose the amount of a block is going to be. So like in this case, I only chose 1. So that means I'm only looking at the register 0001. If I chose 5 as my data count, I'd be looking at the first 5 Modbus addresses and be allocating them to M00 and then the next 4 registers after. So take advantage of data size if you have consecutive addressing. And then there's a checkbox down here to not transmit automatically, or you can transmit automatically by just leaving it unchecked. So if you do not transmit automatically, you will have to create an instruction like this. So I highly recommend leaving the box unchecked, but if you want to control the rate of communication yourself, You can check the box, do not transmit automatically, and then you would create a send instruction like so. So the program ID is the first operand, and then we have this H that's required, so always put it in the H. And then the first two values are either going to be channel 1, channel 2, or your Ethernet channel. So that's going to be you know, your comm device. So whether you're using channel 1 for serial, channel 2 for serial, or you're using an Ethernet parameter. So that's the host, that's the server you're using on the Ethernet module. So we're using 00 here, so that means 232. So RS232, that serial channel. And then the frame number. That frame number is right here. It's the number right here. So this one is 0, but in this one we're choosing number 3. And then the resulting operand is going to store the communication result. It'll tell you if it was successful or if it failed in communication. So first operand is the program identifier. So that is right here, your program ID. When you're making a program, it's assigned ID. And then H is required, and then you have to declare whether you're doing 232, 485, or Ethernet right here. So 00 or 01 or 0x. And then the frame number, that is going to be the actual frame right here. This one's 0, but we chose 3 here. And then the result for your communication. So the send instruction is used for master to slave communication, and then the receive is for master to master communication. So if you need a Modbus master to talk to another Modbus master, make sure you're using the receive instruction. Now, if we're going to use Modbus TCP, we need to make sure that we have an Ethernet module because only the Ethernet module supports Modbus TCP master. If you want to use Modbus TCP slave, the CPU already natively comes with that, hence the term natively, right? So it already is assigned it. You don't have to worry about buying anything extra. But if you want to use Modbus TCP master, you're going to need the Ethernet module CM3-SP01EET, otherwise known as our only Ethernet module for the PLC-S. So you're going to open up the Ethernet module, you're going to assign the IP address, and then you don't have to assign the Modbus unit ID if you're using it as a master because the master doesn't have a unit ID. And then you're going to create a program. You're going to create a master program just like we did with serial. So I'll kind of like make this brief. You're going to create your different frames, declare the data server that you're talking to. And then you're going to fill in your send instruction. So you're going to have send program 2, and then it's 00 because the data server is the 0 Ethernet server. So it's server number 1. And then 01 is going to be the frame that we're targeting, and we'll store that result in M110. And don't worry that this webinar is being recorded, so I will be giving this out after the presentation is over. Do not worry. If you do have questions, feel free to stop and ask. I'm more than happy to assist you with that. So in the HMI, how do I set the HMI to be a Modbus slave? So the HMI can be a Modbus master or it can be a Modbus slave. You can actually turn the HMI into a server. What would you want to do that for? Well, if you want to send the data to like a SCADA software, you're going to need some protocol that is compatible with the SCADA software. And one of those would be Modbus. You can turn the HMI into a server that a SCADA can talk to. So we have that, that capability. That can be found here in the project tree. You can just double click on the Modbus slave here, and then you can choose between Modbus TCP or Modbus RTU. Give it a unit number and then the socket number, or if you're using RTU, just make sure you choose the correct, make sure you use the correct COM parameters and then declare the correct unit number, so the slave ID. So when you're troubleshooting Modbus, my go-to standard, if you're not getting favorable results, is to prove communication with Modbus Poll. Modbus Poll has always been my gold standard for testing any type of Modbus device, because if Modbus Poll can't talk to it, chances are we can't talk to it. And Modbus Poll is a golden standard, in my opinion, in this field for testing Modbus communication. And if you can't get it to work with Modbus Poll, I encourage you, to either call us or work with us, and we will try to help you. But chances are it just doesn't work, and that device is not using the correct architecture of Modbus. So again, to reemphasize, just because something supports Modbus does not mean it's the correct type of Modbus. This protocol is open source, so be careful on which device Modbus you're using. I would say about 95% of the Modbus devices I've come across are all standard, but there's always that hiccup that they say they're using Modbus, that they're not using it correctly. For instance, I did encounter one PLC that had Modbus TCP slave, but you couldn't assign a slave ID to it. And that's important for the protocol because the slave ID is actually part of the packet in TCP. So when you take that away from the packet, it becomes impossible for like us to communicate with that. Most devices out there will have a slave ID within their TCP packet. So I encourage you to double check the Modbus devices that you're purchasing because they might not always be correct. But 95% of the time, it's a pretty good gamble that they'll be correct. And most people don't actually know that because it's an open source protocol. People can change the Modbus protocol to whatever they see fit. On the PLC, if you're using serial for Modbus, we give you little comm lights at the bottom. If those are not flashing, that means the serial communication is not happening. So that's one way to like diagnose your serial communication over Modbus without having to actually log into the software. Another way is to just use the Modbus poll. That's one way of diagnosing your Modbus issues as well. So that is it for Modbus today. Does anyone have any questions? It was a pretty short day today. I know that there were some other protocols listed on the webinar, but I'm just going to briefly cover them. I'm not going to like give a full presentation on them. So I'll open up the Canvas software right now and kind of talk about them briefly. I'm opening the software right now. One second, it's loading. All right, so here's the Canvas software. I'm going to open up a project. At the top left, if I go to project properties and I scroll down, we can see that we support SMTP. So SMTP is the first protocol I want to go over. If you don't know what that means, that is an email protocol. So we can send emails with our HMIs. You can actually test this from the online simulator if you want to before committing to a hardware purchase. A lot of the protocols, or all the protocols technically, you can test from the online simulator because we enable the gateway for 30 minutes. But once that 30 minutes has been exhausted, you will have to refresh the simulator if you want to continue to use the gateway. That's one way that we deter abuse of online simulator because it's HMI software that needs to be deployed on an HMI. So if you didn't know, SMTP can actually be used for texting. So for example, if I wanted to send an email, of course, I would enter the server name. So like I think it's like smtp gmail.com or something like that. That can be like the server name. And then there's going to be a port number that you need to figure out. And then the requires authentication. You're going to insert your username. So it could be like username at CIMON.inc.com. And then a password, right? And then I'm just inputting password. So I think it's like 876 or something like that. But you will have to identify the server port number for a Gmail, and you'll have to identify the domain of the Gmail service. So I think it's smtp.gmail.com. And then you can send a test email like this as well. So you can just do that from this. You don't have to actually use the online simulator if you don't want to, but you can test the functionality with an online simulator. Now, to add on to that, when you're targeting something, you can target a phone number. So you can send text messages with your email, essentially. So if my phone number was this, and I wanted to send an email to it, and I had Verizon as my carrier, I would send an email to this number at vtext.com, and that will actually not send an email. It will send a text message to this phone number. So most phone carriers have a email domain as such. If you send an email to this domain, it'll just send a text message right here. So there's some duality with this feature. You can use it for email notifications or you can use it for text notifications as well. And this is not a paid service. This is all free. This is complimentary in the software. So if you're using the hardware, the CIMON HMI, this feature will automatically be deployed with your hardware. You can just use it. All you have to do is enable it. Other protocols that I wanted to kind of mention, if we go to the IO device editor, which was located right here, of course, we have Modbus, right? That's what we just beat to a dead pulp. But then we of course have Ethernet IP as well. So Allen Bradley's protocol, ODVA, or Allen Bradley's individual modules. So control logics, compact logics, micro logics, micro 800, or ODVA. You can talk to any Ethernet IP device out there on the market. Another one I wanted to mention was OPC-UA. So we have, this is that protocol I was talking about. We can be a client or a server. And then as well, we have Siemens S7. So those are some pretty hot names in the industrial automation market, and we cover all of them. We are going to be adding more protocols to this list. This list is not inclusive, and my software is not even updated to the latest release. So our latest version is 4.1 or 4.0, and I'm on 3.0.1 right now. So I'm a little behind. My apologies, but our protocol list has grown by 4 protocols since that release. We added 2 more client protocols and we added 2 server protocols. If I go to serial, we also have a lot of protocols as well. We have Allen Bradley DF1, we have Hallam Loader, Mitsubishi, Modbus, Omron, and etc. And then if I want to be a server, so this is that server that I was talking about, like turning the HMI into a server versus a client. Typically your client, 90% of the time. But if you want to share data with a SCADA software or the cloud, you're going to go to the server and you're going to enable either Ethernet IP server, MQTT JSON publisher, Modbus, OPC-UA, or Sparkplug Edge node. So my favorite protocol from this list is going to be the MQTT because it's the least demanding protocol and it's IT friendly because it's like a one-way traffic, right? Because you're just publishing, you're just sending data to the cloud. So it's okay to like hole punch the network on the going out, but like we don't want like bi-directional communication. IT people don't like that, and you're gonna end up with a lot of arguments with them. So we want to be IT friendly, and MQTT is one of those IT friendly protocols. And I have a video on our LinkedIn or our YouTube showing this protocol, demonstrating it. So I recommend checking that video out for MQTT. You'll see that I'm talking to MQTT FX, and then that is in turn talking to Mosquito. So there's the publisher, subscriber, broker model. So I believe it was FX that was the broker, and then Mosquito was the subscriber, or it might be they're mixed, or they might be the vice versa. But anyway, it's not your traditional like client server model where it's just like one device. Like with MQTT, it's like a manufacturer, distributor, end user model. You have the manufacturer sending data to a distributor, and the distributor takes care of that bandwidth and sends the data out to the end users. And why would you want this type of model? It sounds very convoluted and tedious. I mean, it's a little tedious to learn at first, but there's a lot of old devices on the network, and trying to get them to talk to the cloud is not going to work. You're going to overburden that device. It was not made with that technology to handle that type of bandwidth. So what you'll do is you'll send the data to a distributor, okay, aka the broker, which can handle that type of bandwidth. And then in turn, that broker will send data to the subscriber, aka maybe the cloud, or maybe the cloud is the broker, etc. But regardless, we can be that bandwidth threshold for you, where like we will publish data to the cloud. So your serial devices or your other Ethernet devices that are communicating on maybe 10 megabytes per second can actually send data to the cloud. So that's one protocol I would take advantage of. That's why it's my favorite. We also have a Modbus TCP server and the Ethernet IP server as well in OPC-UA. So we can be a server for any type of cloud or any type of SCADA deployment out there on the market right now. And that's pretty much all I wanted to talk about today. We do have 7 minutes left. You can stop me, ask any questions, but I will be cutting my mic off right now, and I'll just end the webinar at 10 a.m. or 10 p.m. or 10 a.m. if there are no other questions.